Hello and welcome back to another episode of Math with Sohn. Today we're going to be dealing with free body diagrams in AP Physics 1, dealing with static equilibrium, meaning they are not going to be moving. Okay, so that means everything is going to be all equaling zero essentially when we're done. If things are moving, then you got different stuff going on. Okay, so this first problem, we got a 1 kilogram mass that's being hung by a string as shown, and the first string makes kind of sense. It's being like horizontal. But the next string is being held at an angle. And all of this is being held perfectly still. It's not moving. We got an angle that is 30 degrees right here with the horizon. We want to know the tension of the horizontal string. Well, finding the tension of that horizontal string will involve us recognizing that this T of X, I'm going to call it, must be equal to the horizontal component of this guy, which I will be calling Tx1. Okay? Now there's also Ty1, and we're going to call this the T of R for just the tension of the actual string itself. So with that in mind, there's one other thing that we need to recognize that is going to be apparent, and that would be the force of gravity pulling down on this as well, because all of these are in equilibrium, so gravity must be canceled out in some way. With that in mind, knowing that this is not accelerating, that would indicate that this horizontal component, T of X, and this horizontal component over here, this Tx1, they must be equal, because they're canceling each other out. It's not moving closer to this wall, and it's not moving further away from that wall. They are balanced. Okay, you may see it as this: the sum of all forces in the x direction must be equal to 0, which means Tx and Tx1 will be canceling each other out, and they'll be equal to 0. I like just thinking that they will be equal to each other like I have here. Now, with that in mind, we would know with this 30 degrees that Tx1 is essentially going to be cosine of 30 times the T of R, but we don't know the T of R, so that's not very helpful, but it will be used later down the line. In order to solve this problem, because we have Tx and we have Tr, we can't solve it yet. We need to deal with the vertical component first, because the vertical component can be dealt with the same exact way. We got Ty1 must be equal to mg, because this vertical component must be canceling out gravity. So that means that Ty1 must be equal to mg. Well, what is Ty1? The same type of thing. It would be essentially sine, because it's the opposite of the 30, sine of 30 times Tr would equal mg. Well, let's solve for Tr. If we solve for Tr, then we'll be able to plug in Tr, and then we'd be able to find the tension of the horizontal, which is the main question. Okay, so with that in mind, we got sine of 30, that's 1/2, times Tr will equal m. What's the m? Well, that would be the mass. This mass is a 1 kilogram block, times gravity, 9.8. So if we do that, we would end up with 9.8 divided by 0.5, which ends up being the tension of the regular, like, angly string would be equal to 19.6 newtons. All right, that's great. If we know that that is true, then we would have Tr to plug in over here, 19.6. I think I said 19.8 the first time. So Tx would equal cosine of 30 times 19.6 newtons. What's cosine of 30? Cosine of 30 is an ugly number. It's square root of 3 over 2 times 19.6. And we get our final answer for the tension in the x department, technically x sub 1, will be equal to 16.97. And they're all the same. This part right here would be 16.97. So would this part right here, 16.97 newtons. Okay? Moving on to another one. This next one is going to be a very similar thing, but instead of dealing with the tension being on the horizontal part, it's going to be kind of like pushed upwards. All right, so we got this 3 kilogram block. It is being pushed upwards by the wall with a force of 15 newtons. So this time we know the force, and we also know the angle, but we want to know the normal force of the wall and a few other things. So here, the force of this angle is 15 newtons. The angle is still 30 degrees, so that's convenient. 30 degrees is kind of a nice number. All right? So what do we know? Well, we know that however much we are pushing on this in the x direction, which we'll call x sub 1 right here, that x direction must be equal to the normal force that's being pushed. Whatever we push towards the wall will be pushing back towards us, according to Newton's third law. So what is the normal force on the wall of the block? Well, that will relate to the x direction. So we would have cosine of 30 will equal adjacent over hypotenuse. I'm going to do this one full out, x over 15. Well, if we multiply by 15, 15 cosine of 30 would equal x. And that would tell us what this part is, as well as the normal force that would be pushing back against us. So what is 15 times cosine of 30? That would be equal to about 13, it's 12.99. 13 newtons would equal x, which would also equal your force normal. All right, so part 1 done. What is the magnitude of friction present between the block and the wall? Remember that these are static problems, so it's not actually moving upwards. We are pushing against this block as hard as we can in this direction. We're pushing against it as hard as we can in this direction, and it isn't going anywhere. This must be a very heavy 3 kilogram block, or maybe it's a little tiny bug trying to push it up. Okay, so what is the magnitude of friction? The friction has to completely cancel out all of this. Okay, so we need the y component, the force of y, Fy, and that force here must completely cancel out this force here, which is the force of friction. So that would mean that this friction is going to have to deal with gravity and the force of sine, so to speak, that is pushing with it. Okay, so we have gravity, which is mass times acceleration, which would be force equals mass times acceleration. The acceleration of gravity is 9.8. If we were to put that with the force of friction, so to speak, let me rephrase this. We have the force of friction. That is the part pulling us, like acting against what we're pushing upward, right? That would be acting against what we're pushing upward. So we would have the sine part taking away the force of friction, and it would be taking away the force of gravity. That must be equal to 0. Gravity is pulling down on us, friction is pushing against us, and sine is the only thing that is moving us upward. Okay? So let's write that again. Sine is going to be with 15 newtons sine of 30, because we got 15 here, and opposite over hypotenuse gives us 15 sine 30, minus the force of friction, we don't know that, we're solving for that, minus the gravity, which would be mass, this is a 3 kilogram thing times 9.8, that all must equal 0. Okay? We do this solving process. We got 15 sine of 30. That equals 7.5 newtons. Minus 3 times 9.8 would be minus the force of friction. Minus 3 times 9.8 is minus 29.4 newtons. Must equal 0. So 7.5 minus 29.4, ends up being negative 21.9 newtons. But remember, we also have this minus force of friction here equaling 0. If we add the force of friction over, or if we add these things over, we'd find out that the force of friction would be 21.9 newtons in the negative direction because it is pushing us downward, but that would be the force of friction. So to recap that, because that was a lot, the main thing that we need to recognize is how do we orient these three forces? Friction was pushing against us, gravity was pulling down on us, and we, in the y department, we were the only thing moving this block up. So you could think of it in a few different ways. I thought of it as the y department was having friction acting against it, negative friction, and having gravity acting against it, negative gravity. That would have to equal 0. The other way you could have thought of that was the y department, the sign, must be equal to the force of friction and gravity added together. There's a few different ways that you can think of it that will still make it work out and make it all make sense to you. Okay, sometimes you might start it and realize you may have set it up a little bit funky. So be very careful when you're setting up this pluses and minus thing. You know that they're equal. Make sure you recognize how they're equal, why they're equal. Okay, that's going to do it for this one. Until next time, stay positive, my friends, and I will see you all later. Bye.